Welcome to this video on simple harmonic motion. So when we're talking about simple harmonic motion, we want to describe oscillators, which are objects which repeat a motion again and again. So like if you're pushing your kid on a swing, or the shock absorbers in your car, or there's even a version of this in the electrical circuits in your radio. So we want to be able to describe these oscillators. The basic requirement in fancy physics language is that they want to return to equilibrium in a linear fashion. Now, well, what does that mean in English? If I stretch this spring from equilibrium just means where it wants to be. Well, as I stretch it, stretching just a little bit is easy, but if I try and stretch it more, it gets harder and harder and harder, and then it returns back to equilibrium, where it was before. So, in mathematical terms, we have an equation that determines how these objects behave. So, this is that the force equals negative kx. Now, what does that mean? That means that x being the distance that we're stretching our oscillator from equilibrium, if I stretch it a certain distance, I'll feel a certain force. If I double that distance, I'll feel twice the force, just like we saw, where stretching it a little bit was pretty easy, and then as you stretch it more and more, it gets harder and harder. Here would be a diagram of an unstretched spring, where the position x from equilibrium is 0, and there is no force. Whereas if we compress the spring, say a distance a in the negative direction, well then the force is in the opposite direction, trying to return the spring back to equilibrium where it was before. That's where this negative sign comes from in our equation. We want the force to return us to where we were. And then similarly for a stretched spring, if it is stretched in the positive direction, where we stretched at some distance a positively, then the force is in the negative direction, trying to return it to equilibrium again.